Hello, this is Mr. Morgenstern, and I'm back with Lab 8, Conservation of Energy 2. So what we're going to do today is we're going to use the air track with a cart, and we'll have 2 photo gates. We'll place photo gate 1 at some location and then leave it there for the entire lab. And with photo gate 2, we'll move it to 5 different locations so that we have 5 different lengths between the photo gate. Then we will do 3 trials per length, and we'll use 2 different hanging masses so that we will have a total of 30 trials. So 3 by 5 is a 15, and then the 2 will be 30. And so I will give you an Excel sheet with 10 data tables, 5 for one for each length for hanging mass 1, and then 5 more for each length at hanging mass 2. So what we'll start with is we'll weigh our glider and our hanging mass, both the original and the heavier one. And then note that the uncertainty on the mass will be plus or minus 0.05 grams. And this uncertainty comes from being half the smallest unit of measurement on the scale we use to measure the weight. So then we'll set our Pasco box to velocity collisions under the speed setting. And we will send our cart, we'll hold it stationary at gate 1, we'll let the hanging mass fall, and it will be attached to the cart via the string. So the cart will accelerate between the 2 gates, and we'll measure the speed at each gate. So the cart will only have kinetic energy because it just sits on the rail and speeds up. The hanging mass will have a kinetic energy and potential energy. So it has its kinetic energy as it falls, and it has potential energy from gravity pulling it off the table. So at the beginning, or at photo gate 2, where the cart ends, we will say that that is where the potential energy equals 0 of the hanging mass. Then the change in potential energy will be equal to mgl. So m is the hanging mass, not the cart mass. G is gravity, and L is the distance between the photo gates, because that's the distance the mass will fall. And that's what we'll call the change in potential energy. And then kinetic energy will be 1/2 mv squared. And so we'll use little m for the hanging mass, but there will also be a 1/2 big mv squared, which will be the cart mass. Now the v will be the same for both because they're attached together by a string. So then the change in kinetic energy, we can say K2, so this is how fast the cart is moving at photo gate 2, minus K1, and this will be the speed of the cart at the photo gate 1. So now we want to calculate gravity from data. So to do that, we'll plot the change in kinetic energy versus the distance between the photo gates, and we'll have a linear equation. We'll get a line. And then to get gravity from this, we can think that the energy is conserved. So the change in kinetic energy should be approximately equal to the change in potential energy, which is mgl. So then our slope will be delta k over L. So we can write that approximately as delta U over L, which is mgl over L. Our L's will cancel, and we'll get that our slope is mg, where m is the hanging mass, and then g is gravity, which is what we want to find. So on the report, as usual, you'll answer all the questions, and then you'll have 1 or 2 graphs. So we have 2 different hanging masses, so either you can make 2 graphs, one with each hanging mass, and get 2 slopes, or you can make 1 graph with 2 different series on it, 1 for each hanging mass. This is a bit harder to do in Excel, so if you're having trouble, go ahead and just do 2 graphs. So let's look at the experimental setup. Here's our air track. We've used that before. We have our cart, and then we have our hanging mass, our wheel here. So what we would do is, here is the original hanging mass. So this would be hanging mass 1, and I weighed this on that scale. And then what I did was I put these weights on to make it heavier. So this is hanging mass 2, and I re-weighed it, and I provide you with these weights. I also weighed this cart on here, and I provide you with that mass. And then here's photo gate 1, so it's right up against the cart here, and it's at around 54. I give you the exact measurement in Excel. And this cart, or this gate, will stay stationary. I won't move it. This is our second gate. I will move this around to different distances. So now what I'll do is we'll take a sample trial, turn on this. I want to set it to speed and then collisions, and then I'll go ahead and start it. And now it'll get a little noisy when I turn on the compressor here. So I have the air on. All I will do is I will let go of this gate, let it move between the two gates, and then let me go ahead and shut off the thing so you can hear it. That was one trial at one length. We can see this is gate 1, and so the first value of gate 1 was 25.9 centimeters per second, so that was the speed of the cart. Then I switched to gate 2, and I see that it was 90.9 centimeters per second, so that was the speed of the cart through gate 2. And so this was for one length. I would do this 3 more times. Then I'd move to a different length and repeat it. And then I would do it all again with a different hanging mass. And so I'll provide you with all this data, and then you will just have to do the plots and the calculations. So thank you again for your time and joining me for Lab 8, and I'll see you again in Lab 9.